All right, so we're gonna look at some sequences in a candy machine. So first, we're gonna read and understand the problem. So the Food Mart grocery store has a candy machine like the one pictured here. Every time you put in a quarter, 7 candies come out. The machine holds 15 pounds of candy. Each pound of candy contains about 180 individual candies. So represent the number of candies in the machine for any given number of customers. About how many customers will there be before a machine's empty? So first let's find the total when it's filled up. So it'll fit 15 pounds of candy, and each pound has 180 individual candy. So we go 15 times 180 to just figure out, well, how many candies are in there. So I'm grabbing my calculator, and there are 2,700 total candies. So now, how many customers will there be before the candy machine is empty? So if you look, each time a child inserts a quarter, 7 candies come out. So what we can do is go 2,700 minus 7 times the amount of candies. And we want to figure out, well, when is that equal to 0? So we can just solve that. So what I'm going to do is add the 7c over to the other side. And I'm going to write that over here. So that's going to cancel out and make 0. So we have 2,700 candies equals 7c. And I'm going to divide that by 7. And we have 385.7 equals C. So what we'll say is round that probably down and just say it's going to take about 385 customers. Before the machine is empty. So now represent the amount of money in the machine for any given number of customers. So first of all, let's define our variable. So let M be money. And each time a child inserts a quarter. So we're going to say the amount of money is equal to, well, if you put in a quarter, that's 25 cents, so 0.25 times N. And we'll define that too and say, let N be the number of customers. So now to avoid that, the store owners don't want too much money to be in the machine. So they take all the money out when the candy machine has $25 in it. The tricky part is the store owners can't tell how much money is in the machine without opening it up. So they choose to remove the money by judging how many candies are left in the machine. About how full should the machine look when the candy is taken out. So first of all, let's figure out, well, how many customers is it gonna take to generate $25? So we're gonna say, well, the money equals 0.25 times the number of customers, and I'll put N again. And again, we know that the money is equal to $25, so I'll substitute that. So we have 25 equals 0.25 times N. Well, to undo multiplying by 0.25, we divide both sides by 0.25. And we get 100. So this N means after 100 customers, we should empty that. But we need to figure out, well, how much candy is that? So what we're gonna do is say, well, each customer took 100 candies out. So if you remember, if we're representing how much candy is left in the machine, we could say, let C be candy. And then we would have C is equal to, well, we had 2,700 pieces of candy, and each customer takes 7 pieces of candy out. So we could say minus 7 times N, the number of customers. And again, what we're gonna do here is substitute N equals 100 and see, well, how much candy is left. So we're gonna see, well, how much candy is there? 2,700 minus 7 times 100. Then 7 times 100 is just 700, so the amount of candy is 2,700 minus 700. So the amount of candy is 2,000. And we have to figure out, well, how full is that for the machine? So what we're gonna do is make a fraction. So we're gonna say, well, we have 2,000 pieces of candy out of 2,700 pieces of candy. And we're gonna change that into a decimal and then a percent. So 2,000 divided by 2,700. And that gives me 0.74, which is 75%, that's a decimal. So about 3/4 or 75% full.